Hi guys, welcome back to my channel. So what's going on, guys? You know, I'm that to make all these videos, I'm putting my 100% effort. So what's your job? Your job is to watch my videos continuously. Definitely, all my videos will boost your knowledge of chemistry, and you can easily get good grade in your final examination. Maybe A or maybe B, but you have to watch my videos constantly. Don't miss my videos. Okay, then. See, today I'm going to teach you polar covalent bond and non-polar covalent bond. I've already started in my previous video about covalent bonding. Now, why some covalent compounds are polar and some are non-polar? What's the condition that makes the molecule polar and makes the molecule non-polar? Let's see. To discuss about the polarity of the covalent compound, we have to know a small parameter or small unit called electronegativity. Electronegativity is not the energy. Some student getting confused with ionization energy and electron affinity. Ionization energy and electron affinity, these are energy values. Electronegativity is not the energy value, it's the ability of a non-metal in the periodic table. When two non-metal join to form a covalent bond, one of the non-metal has more ability to attract the shared pair of electron. That's called electronegativity. Now, first, let's see what is meant by the term electronegativity. Electronegativity. Okay, electronegativity is the tendency, or it is the ability. It is the ability. It is a tendency. It is a tendency to attract the shade pair of electrons when bonded covalently. So when a covalent bond is formed, one of the element has the ability to attract the shared pair of electron. So we didn't get it. Okay, look at the HCl, hydrogen and chlorine. That's the HCl molecule. So dot and cross structure of HCl, hydrogen has 1 electron, chlorine has 7. 1, 2, 3, 4, 5, 6, 7. This is hydrogen and this chlorine. Mostly the bond is present between the two elements. That's the nucleus and that's the nucleus. This is the nuclear distance and the lone pair of the electron, bonded pair of the electron in between the two nucleuses. But because of the electronegativity power of the chlorine, the two electrons slightly shift towards the chlorine. Look at that. That two electron move towards the chlorine. This is the ability of the chlorine that will attract the shared pair of the electron. As a result, this hydrogen get a slight positive charge and this chlorine get a slight negative charge. This is called partial positive. This is called partial negative. We can't call them as complete. We can't call them as ions. but the distribution of charge take place, which we call as dipole. I will teach you dipole later on. Okay, so some element in the periodic table has more ability to take or to withdraw this pair of electron towards itself. That phenomenon is called electronegativity. Okay, guys. So is the tendency or is the ability? It's just a one mark question. What is meant by the term electronegativity? Okay. Presence of electronegativity make the molecule polar. Okay. So polar molecule. Now, electronegativity increases across the period and decreases down the group. En value, electronegativity, I'm writing just En, which is a short form of electronegativity. Electronegativity value increases across the period and decreases down the group. And electronegativity is the property of non-metal, guys. It's not the property of the metals. It's the property of non-metal. Now, look at that. Nitrogen, fluorine, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So electronegativity value increases like this and decreases down the group. Look at the electronegativity increases across the period, decreases down the group. So nitrogen, when you move from nitrogen to fluorine, electronegativity increases. Electronegativity value increases across the period and decreases down the group. Look. So when you move from nitrogen to fluorine, electronegativity value increases. And electronegativity value decreases down the group, guys. So the highest electronegative value is 4. And which element has the highest electronegative value? Fluorine. Electronegativity value is measured by Pauling scale. It has no unit because it's a tendency. So electronegativity has no unit. It's just a value. It's just a number. Fluorine has the highest En value, which is 4. Fluorine has 4. That's the electronegativity value. See, the phenomenon electronegativity makes the molecule polar. If there will be a difference in the electronegativity, then the molecule or the compound has partial positive charge and partial negative charge. Look at the example. Yeah, look at that example. Look at that one. So, like hydrogen chloride, we have seen just hydrochloric acid or HF, HCl, no HF. Hydrogen and fluorine, hydrogen fluoride, hydrogen and fluoride. Fluorine has the highest electronegativity, so it withdraw or attract the shared pair of electron. So that shared pair of electron moves slightly towards fluorine. As a result, fluorine got slight negative or partial negative charge and hydrogen got a partial positive charge. This makes the molecule polar. More the electronegativity value or bigger the difference between the electronegativity value of hydrogen and fluorine makes the molecule slightly ionic. I told you that no covalent compound is 100% covalent or no ionic compound is 100% ionic. Ionic compounds have certain percentage of covalent character. In the same way, covalent compounds also, they have the percentage of ionic character. Because of the electronegativity differences, they have partial positive charge and a partial negative charge, which makes the molecule slightly ionic. That's why they are dissolved or they are soluble in polar solvent like water. HF is soluble in water because it is polar. You can easily notice ions are formed, no doubt partial ions, not complete ions, partial. So it will dissolve in water. On the other hand, look at the non-polar molecule. So how can we check the non-polar compound? If the electronegativity difference is 0, look at that. If delta En, what's delta En? Electronegativity value is equals to 0. Here, if delta En, difference in electronegativity, is not equals to 0, fluorine and hydrogen, there will be a difference in electronegativity value. Can you give me the example of non-polar molecule? Any non-polar molecule? Hydrogen and hydrogen. Hydrogen and hydrogen. Both these two are hydrogen, so they do not have ability to attract the shared pair of electron. So this bonded pair of electron is exactly lies between two hydrogen atom. So this is the hydrogen atom, this is the hydrogen atom, this is called the nuclear distances. So that's the nucleus, that's the nucleus. So exactly the bonded pair of electron lies here. Because the electronegativity difference is equals to 0, which makes the molecule non-polar. We have some other example of non-polar molecule. So non-polar molecule will not dissolve in polar solvent because we cannot find any charge separation. Here, look at that. Here there is a charge separation or charge distribution. This charge distribution, we call it as dipole moment. There is a partial positive and partial negative charges. So this is also called charge separation and a dipole. Dipole means on the molecule or on the compound we have positive end and a negative end. That's called dipole. There is no dipole here. Okay. Now one more example of non-polar compound. Non-polar. So many examples. How can we know? Means what's the condition for non-polar compound? Electronegativity difference is equals to 0. That's the main condition. Now, some more molecules of non-polar compounds? Yes. Any idea, guys? Do you want to give me some example of non-polar? Chlorine molecule, bromine molecule, iodine molecule. Two same atom. Obviously, there's no difference in electronegativity. So all of these molecules are non-polar because the electronegativity difference, the delta En value is equals to 0. Look at that. Delta En is equals to 0. And a non-polar. This is non-polar and polar. HF, HCl, HBr, HI. All are polar. Polar covalent compound. Polar covalent compounds, they are dissolved in water. They are soluble, not 100% soluble, but they are soluble. When you compare polar covalent compound and ionic compound, which one are more soluble in water? Ionic compounds. Because in case of ionic compound, we will get separate ions like Na plus and Cl minus. Here we are not getting H plus separate and F minus separate. No doubt there is a charge distribution which makes the molecule slightly ionic. That's why they dissolve in polar solvent. They are soluble in polar solvent. Like water is a good polar solvent, ammonia. They are soluble in polar solvent. Now, look at the HCl, HBr, HI, all are polar. Now, this charge distribution is also called dipole. Let's do some discussion of dipole moment. Okay. Now, the dipole moment. Do we have a dipole moment in non-polar compounds? No dipole moment. There's no charge separation. But here we have a charge separation. Now the dipole moment. Dipole moment. Dipole moment, how we measure? It is the distance between, like for example, hydrogen and fluorine, hydrogen fluoride. It is the distance. Suppose this is the hydrogen molecule, this is the hydrogen atom, this is the fluorine atom. Here we have hydrogen, here we have fluorine. This is called interatomic distances. Yeah. So dipole moment is the product of distance from here to here and the charge separation. This distance and the charge separation and the quantity of the charge, partial positive, partial negative. So is the product of quantity or magnitude of the charges and the interatomic distance. That will give you dipole moment. Dipole moment is a vector quantity. Any idea about the vector quantity, guys? I know, it's too much. Vector quantity is like a physical quantity, and the vector quantity has both a magnitude and a direction. And a scalar quantity has only magnitude. I will give you just a few examples of vector quantities and scalar quantity. Like time is a scalar quantity. It has no direction. And the volume is a scalar quantity. But look at the force, and we have a velocity. I'm not teaching physics, but I'm just telling you vector quantity. What is meant by the term vector? Vector quantity. Dipole moment is a vector quantity. It has direction as well as magnitude. See, it moved from partial positive to a negative. Like you have to show the arrow like this. So suppose this is HF, hydrogen fluoride, partial positive, partial negative. We have to show the movement like this, from positive end to negative end. This is called dipole moment, which is a vector quantity. So it has a direction and magnitude. Vector quantity is a quantity which has both the direction as well as magnitude. For example, velocity. Velocity is a vector quantity. It has a direction as well as magnitude. Acceleration is a vector quantity. Okay, now dipole moment. Dipole moment. So what is the importance of this? More the charge separation, more will be the polar bond. More will be the polar bond mean more percentage of ionic character. For example, hydrogen, chloride, HCl, partial positive, partial negative. So the dipole movement move from positive to the negative end. More the charge separation, more the value of dipole moment, more will be the charge separation, more will be the ionic character, more will be the polarity, and it is easily dissolved in polar solvent. Now, it is a vector quantity. We know that. It has a unit, guys. It has a unit. Dipole moment. That was a past paper question. Any idea what's the unit of dipole moment? Debye. D-E-B-Y-E. Debye is the unit of dipole moment. Now, I told you how can we check whether the molecule or the compound is polar or non-polar. The first condition is difference of electronegativity. First, what's the main condition? How can we check difference in electronegativity? En value different. If the En value is not equals to 0, simply molecules or compound, molecules are said to be polar if difference in electronegativity is equals to 0, like chlorine molecule, iodine molecule, bromine molecule, then the molecule is said to be nonpolar. Molecules are said to be non-polar. Suppose I'm giving you one example of BF3. BF3 is a polar or non-polar. And how can we decide? By using this criteria or some other criteria. Okay, let's check. Mostly this happen in two similar atoms. If suppose we do not have two similar atoms, then how can we check the polarity of the molecule? We have one more condition called dipole moment. We have to focus on dipole moment, which is a vector quantity. Look at that one. Check whether the BF3 is polar or non-polar. See, it's a polar molecule or non-polar molecule. BF3, boron trifluoride, fluorine, a fluorine, and a fluorine. There is a difference in electronegativity, guys. Boron has different electronegative value and fluorine has different. So the condition, first condition, if delta En, difference in electronegativity, is not equals to 0, then the molecule is said to be polar. But that's not right. This only applicable for the molecule of same atom. Now, how can we decide this molecule is polar or non-polar? We will draw its dipole. So we know partial positive, partial negative, partial negative, partial negative. So this bond, this dipole goes in this direction, this dipole goes in this direction, and this dipole goes in this direction. If you're getting confused with dipole, you think this is a kind of force. So one force goes here, one force goes here, and one force goes here. You add up these two forces, that's the resultant of that one. This is one force going up, and this is one force going down. Both the forces cancel out. So there is no net dipole moment. If there is no net dipole moment, then the molecule is said to be non-polar. Past paper question. Why ammonia is a polar molecule and a BF3 is a non-polar molecule? Look at that. So the reason behind is, no doubt, the difference in electronegativity value is there, but there is no net dipole. Best answer, there is no net dipole or resultant dipole moment is cancelled off. Why BF3 is non-polar? Answer, simple answer, because there is no net dipole. I have seen the mark scheme, guys. In the mark scheme, it is mentioned as simply there is no net dipole. No net dipole, or dipole cancel out. Dipole movement. Dipole movement cancel off. Let's check the ammonia. Ammonia, nitrogen, and 3 hydrogen. Same thing. Instead of ammonia, take NF3, nitrogen trifluoride. NF3 is a polar, whereas BF3 is non-polar. That was a past paper question. Let's check the NF3. Why NF3 is polar? Okay. Why NF3 is polar? Nitrogen, fluorine, 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 and lone pair. Okay. This is the molecule of nitrogen trifluoride. Which one will become a partial positive? Fluorine has less electronegative. The electronegativity value of fluorine is more. Nitrogen is less. So nitrogen got positive charge a negative charge, a negative charge, a negative charge. So this goes here, this goes here, this goes here, and because of the lone pair, that goes up. So one like this like this, that's like this like this. So all cancel. No, we can't cancel. So these three in one direction, we can't cancel. Sorry, my bad. We can't cancel here. All three goes in one direction. Only one goes up. So these three in downward direction, and that's upward direction. So we cannot cancel. Why NF3 is a polar molecule? The reason behind is NF3 is a polar because there is a net dipole. The dipole cannot cancel here. There is net dipole. That's the reason. So I want to stop my video here. We will do some more questions based on dipole and how it is useful to figure out the polarity of the molecule. Please, I'm requesting you have to watch my videos. I know you're in summer break and you're not in a mood to study, but even though when you have a leisure time, when you're free, at least 30 minutes, guys. My videos are not more than 30 minutes, or my maximum video time is 30 to 40 minutes. Just utilize your time for 20 to 30 minutes and watch my videos. Thank you.